Hello everyone. This lecture is about British Standard BS8888. Normally, either you are studying Mechanical Design A or Mechanical Design B. We just keep telling you that the drawings that you produce in your report should comply with the British Standard BS8888. So the aim of this lecture is to help you to get some understanding of the technical drawing standards. I've just broken down this lecture to a number of sessions because I didn't want it to be quite long. I'm just going to record a single video for each session. So in session number 1, I'm going to talk about introduction to the British Standard BS8888. This will be followed by some general drawing conventions in session 2. Then I'm going to talk about dimensioning according to the British Standard BS8888. This will be followed by some indication of tolerances that you need to include in your drawings. In session number 5, we're going to talk about projection, the third angle projection and the first angle projection. In session number 6, I'm going to introduce sections and views. Then in session number 7, I'm going to talk about what's called GD&T, or geometric dimensioning and tolerances. Then in session number 8, this is going to be on datums. Datums are related to GD&T, so you need to define datums in order to include GD&T in your drawings. In the last session, I'm going to show you some examples of this GD&T according to the British Standard. So this is the first session. It's an introduction to BS8888. So obviously, why do we need even like drawings? It is quite important because words only are inadequate for engineering communication. So this just means that we need to have like a common language between engineers. We have our own way of understanding ideas and concepts and to communicate them. So in order for all engineers all around the world to understand the same language, so we should learn this language. And this language meaning that we need to have one way of communicating ideas and concepts. And this is the engineering drawings. So for example, the design department just work on a specific project and then they develop some drawings and then they pass those drawings to the manufacturer. So the manufacturer understands the language and he or she can start manufacturing the product. So what is quite important here about standards is that the communication error is quite expensive in engineering. So if you do not comply with specific standard, so there's going to be like wasted materials, wasted machining times, labor time, etc. We need to avoid this, and in order to avoid this, we need to strictly comply with like a standard. It is therefore critical that you always consistently follow a specific standard. In our case, we are following the British Standard BS8888. So there are 4 categories of drawings that you should keep in mind for your knowledge first in mechanical engineering. The first one is some sort of concept drawings or sketches or schematics. So this is like the crude hand-drawn sketches without scale, without using any instruments and so on. So design layouts is the second category, and it contains a little bit more details compared to the concept drawings. It just shows the relationship between components and some more details about each and every component. Then the third category is the detailed drawings, or the manufacturing details or manufacturing drawings. This is where you need to communicate lots of information so that the manufacturer can produce or can manufacture the part that you have designed. And the last category is the assembly drawings. So if, for example, you just produce or manufacture some parts, but in the end, in order to have a proper function, we need to put these parts together so that they function and they do the job that they are intended to do or designed to do. So the first one is concept drawings or schematics. It concentrates only on the principles and the general relationships between components. The precise scale is not required, is not important at this stage. It's just sketches or block diagrams at this stage, at the very early stage. Then it is hand-drawn without using any instruments. It's quite crude drawings at this stage. And the intention here is maybe to use these drawings or these sketches or these concept drawings for a preliminary discussion with clients, with marketing teams, sales colleagues, and so on. So what you see here on the screen is like a concept drawing or a schematic for a small concrete mixture. So you see here 3 different solutions, and then they are hand-drawn. There are no scales here used, no instruments. It's just a concept without any dimensions even. If, for example, this is the concrete mixture, so the first concept here is talking about having a motor, then having 2 pulleys and having a pelt, and then having like a worm wheel gearbox. The second one is talking about having a motor, then flexible coupling connected to a worm wheel gearbox. The third one is talking about like a motor connected to a pulley and belt and 2 pulleys, then connected to a spare gear drive. So these are kind of like hand-drawn crude drawings or schematics to just have the discussion about the kind of decision that we can decide. The next category is called the design layouts, and here is like if we focus on little bit more details compared to the schematic drawings. So it is the step between the concept drawings on the previous slide and the detailed drawings that is coming next. So this is kind of a step between these 2 categories. They are not allowed to leave the design office, but they give some more details about the drawings. For example, you see here, if you focus on these design layouts, you'll see that compared to the schematic drawings previously, you see here more relationships are defined between components, more details about the parts and their locations, some sections, and so on. So this is kind of, we decided on one concept, and then we introduce more details about this particular concept, how parts are connected together and what is the relation between parts. This is the design layout. The third category is called manufacturing details or detailed drawings, or sometimes it's called manufacturing drawings. So the idea here is that they are manufacturing instructions for individual machine part. So if you are asking the workshop to manufacture a specific part for you, so you need to give them some instructions, some manufacturing instructions, including the dimensions, what kind of material, what kind of surface finish, what kind of tolerances, some sections and views to show the part and so on, some details about all these things. So these drawings, um, uh, they are drawings for individual components. So when we say like manufacturing details or detailed drawings, we're talking about a single component each. And we just manufacture those components if they are not available to be bought from a specific supplier. And so in these like manufacturing details or detailed drawings, all the information necessary to enable manufacture must be included. Um, for example, all the essential dimensions and their tolerances should be included. Any machining marks and surface finish requirements should be included. Any material specifications, heat treatment procedures, and so on. All these information should be included in the manufacturing details drawings. Any protective treatment, decorative finishes, any special tools, jugs, fixtures, any instructions for the identification of parts. So see here, lots of details you need to include for detailed drawings. It is like some instructions, so you don't need the workshop to come back and ask you about some more details about the specific part. So you should include all this information for them to just simply use your drawings and manufacture the part without coming back to you. What you see here on the screen is an example of part drawings or detailed drawings, manufacturing details. And see here you have two views, one on the left-hand side, one on the right-hand side. This, for example, could be a front view, and this is the side view. And what you see here, lots of information about the part, lots of necessary information about the dimensions, tolerances, surface finish, and so on. Of course, maybe at this point you don't understand everything that is shown here, but hopefully by the end of this lecture you should be able to identify, for example, that this is the symbol for a datum when we choose a datum A and another datum B. And then, for example, here this dimension is 30 plus or minus 0.5. This is the tolerances that are given for this part. You see, for example, here this 16 millimeter dimension is in a box, where it means that the tolerances is defined as GD&T, or through the geometrical dimensioning and tolerances. So here, for example, this feature control frame defines the location of the center line, this the symbol for location, and it should be within like specific tolerance 0.2, and there is a relation between this center line here, which is the location of the center line, with both the datum A and datum B. So we'll talk about this more in more details by the end of this class. So here is another example of what's called fabrication drawing. And in fabrication drawings, we are talking here about different components are permanently joined together. It's not an assembly drawings, because in assembly drawings, you can just assemble, disassemble easily. But these are components that are permanently joined together. That's why they are called fabrication drawings. They are permanently joined together using welding, brazing, adhesion, or any other method, but eventually they are just put together. And you see here, all the constituents should be fully specified. So here in this case, for example, we have the drawing area. We have what's called title block. We are going to talk about title block as well. We have here the bill of materials, the items numbers. They are defined here in this using these balloons 1, 2, 3, and then they are. You can relate what is written here to these parts. And each part has a part number, it has a description, it has a material, it has a quantity defined. And see here the dimensions and the GDT tolerances are defined as well. Then the datums are defined. So you should kind of understand this language in order to be able to read this kind of drawings. See here, for example, some like welding symbols are defined. These are the kind of things that you should learn out of this lecture, and also by reading more details about the British standard BS8888. The fourth category is assembly drawings or general arrangement, or sometimes they call it general assembly drawings. They are obviously used to inform production department on how components are assembled together, because eventually assembly drawings means that after you manufacture those like individual components, you just need to assemble them together in order to have a useful functional assembly. So in these assembly drawings, you need only to identify or define the overall or key dimensions included in the drawings. You don't like define the tolerances and the detailed dimensions of each and everything. It's not required here. You can also define the mass and the center of gravity of the assembly. The assembly drawings can also be used as a checking procedure before you put the components together. Using these assembly drawings, you can just make sure that they are going to just assemble together. They are going to fit and function together easily without any problems, and then they are going to perform as required. What you see here on the screen is an example of an assembly drawings. Here the assembly drawings is the middle. Here you have a bill of material. Again, you have all the item parts, and you have these balloons so that you can relate. For example, number one here is the mounting plate, the quantity is 1, and this is the part number. So you can relate what is written here on the bill of material to what is on the drawings. You have the title block. It's not like completed here, but we'll see how to create this one. You have here some notes as well. They are written in capital letters, and then they are related. For example, number 4 here. So the component number 4 has a note 1. So grease before assembly. So it just tells whoever is assembling these parts to just add grease here before finalizing the assembly. For example, here for these bolts, there are some notes written here. It says 2 times, means that we have 2 bolts. And then it says the torque tightened to 16.5 Newton meter plus or minus 10%. So you just keep adding notes here. They have a half section, so this part, this half right-hand side part is section, and the left-hand side is not section. You could have included here the overall dimensions as well. So the assembly drawings represents the relative position of parts, how they are assembled together, and then it depicts the constituents of a parts list. So here is another example of assembly drawings. You see here we have 1, 2, 3 views, and then we have some sections, and then this section line here, YY. So we have a section YY. So this is when you cut this part into 2 parts, what you see from inside, so you can reveal the details from inside. We're going to talk about sections as well. And here it shows here the title block. Some more details are written here. We are going to talk in details about title blocks. For example, it says dimensions in millimeters, so all the dimensions are in millimeters. You have these balloons here, and then you have the bill of material, you have the items and their numbers, their materials, the description of each and every part here in the assembly. So that's the end of session number 1. I'm just going to stop recording, and then I will start session number 2 in separately.